In the past sections, we've been solving quadratic equations. We did it by the factoring method. We've done it by completing the square and by the quadratic formula. We're going to now switch over and start talking about the graphs of quadratic functions and how it all kind of ties together. So standard form, ax squared plus bx plus c is equal to 0. And of course, for it to be quadratic, it needs to be a second power. So quadratic form. Its shape is called a parabola. These should all be reviews for you. A parabola can either look like this or like that, either open up or down. The vertex is either the low point on the graph, as in this one, or it could be the high point on the graph, as in this one right there. So over here, you can see we're going to say that this then is the vertex. And the vertex, when given just a generic representation with ordered pairs, it's not called x and y, it's called h and k. So you're going to find as you study that special points on geometric shapes on a coordinate plane are often called, the ordered pairs are often called h and k. So this is h and k, which is going to represent the vertex. The axis or line of symmetry is here. So this is the axis of symmetry. And it's this line right here. It's a vertical line. And recall that vertical lines are always x equals to hoi vux. So vertical goes with an x. X equals to whatever the x value is of this point. And since this point has got an x value of h, it's going to be h. So whatever the h value of the vertex is, will be what the axis of symmetry is going to have in its equation. So I'm going to put here x is equal to h. What's also true about the axis of symmetry is when you say the symmetry, that means that as you go from that axis to the sides, let me find a place where it kind of crosses right here. Looks like it's 1, 2, 3, this direction. It will also be the same that direction. So it splits the parabola exactly in half. All right, so let's look at the bottom half of this. Concavity, what that means is when I said a parabola can either open up or down and be a function, this one here is going to be, when it opens this way, this would be concave up. And when it opens this way, this would be concave down. These are the x-intercepts, so x-intercepts. And they're going to match with the solutions to the quadratic equation. So I'll just kind of put solutions. Some other words that they're called are roots, or they're also called zeros. So those all kind of have the same term there, so right there. So, and then down here, here's our y-intercept. So remember that for an x-intercept, the y value is 0. And you can see that there's 2 of them here. There's not always 2, as you'll see as we go through our examples. But I'll call this R1 for root 1 and R2 for root 2. So, but the y value equals 0 always. And for the y-intercept, the x value is going to be 0. So this is 0, and then some value here, I'll call it b, for the y value. Domain, so take a look at this. Remember, the domain goes from the left to the right. And even though they're not showing arrows, I'll put the arrows right there. The left is going out continuously to the left and then continuously to the right. So it does not end. So we're going to say that the domain is all real numbers. All right, so let's look at a parabola, a quadratic function, and answer these questions. Vertex is the low point, so it looks like it's -1, -9. So we'll say that this is -1, -9. The axis of symmetry goes, it's a vertical line that goes through the middle. So it's going to be x is equal to the x value of the vertex, -1. You've got to get the x equals to, or it's not a line. Concavity, that's up. X-intercepts, that's where it crosses the x-axis. So it looks like that's crossing at -4 and at 2. The domain's going to be all real numbers. You've got those arrows there. And the range, the y value, is going to go from the low point on the graph to the high point. And you see it goes infinitely up. So the lowest point then is -9. So we're going to say that y is greater than or equal to -9. All right, so we're going to, let's skip down and look at C. I'll let you do B. So I want you to try this one. You can watch me do C first and then come back and try it. So on C, the vertex then is going to be here. So it looks like it's at 3, 0. So over 3, up 0. Axis of symmetry goes through the middle. So the x value is 3. So x is equal to 3. Concavity is down. The x-intercept, so there's only one of them here. So it's just 3. The domain is all real numbers, and the range, this time I have a high value, and it's going to be going down infinitely. So we're going to say that y is less than or equal to, what's the highest y here? 0 for our answer. All right, so y'all come back and try B.